Creating ionic bond supplement, more moving of electrons to form ionic compounds. If we take a look at potassium, potassium is a group 1 element, so it has one valence electron. When we consider our table, we have one valence electron. We want 7 more to get to 8, so we will lose that 1. If this is bonded with iodine, a group 7A element, it's going to have 7 valence electrons. And here we have 7, and we want 1, so this will want to gain 1. Potassium can give up the electron to iodine. Therefore, we'll have potassium with a positive charge, iodine with a negative charge. They'll attract, forming potassium iodide, Ki. If we look at another example, sodium, another group 1 element with 1 valence electron, and sulfur, a group 16 element with 6 valence electrons. Well, sodium has 1 valence electron. It wants to gain 7. It has 1, wants 7, so it will lose the 1. Sulfur has 6, wants 2, so sulfur will gain 2. Sodium will give up its 1 valence electron to sulfur, so we're going to need a second sodium atom with 1 valence electron to give up a second valence electron to sulfur. So our resulting formula now is Na2S, because there's 2 sodiums and 1 sulfur. If we consider magnesium with 2 valence electrons and oxygen with 6, well, in this case, magnesium can give 1 and 2 electrons to oxygen. Therefore, magnesium and oxygen, 1 atom of magnesium, 1 atom of oxygen, our formula is MgO. If we look at calcium, another group 2 element, and bromine, a group 7 element, calcium can give 1 electron to this bromine atom, and it still wants to get rid of a second one. So if it's going to get rid of a second electron, a second bromine atom has to be around to accept it. This results in a CaBr2 formula. One of the more complicated one that we're going to look at, magnesium, 2 valence electrons, nitrogen with 5. Magnesium can give up 2 electrons, and this nitrogen atom can take both of them. Then need another magnesium atom, and it can get rid of 1 electron, but this nitrogen is now full. So a second nitrogen atom is needed to accept magnesium's second valence electron. In this case, nitrogen still has place for 2 more electrons, so we'll need a third magnesium atom to give up the other 2. Now there are 3 magnesium atoms and 2 nitrogen atoms.